really appreciate the short video because this is my second take because the technology didn't work. So I hope you feel the love since I'm doing this a second time for you all. Okay. All right, so we're starting chapter 3, which is all about parallel and perpendicular lines. We're going to go over some very important definitions in this section, not a lot of arithmetic, actually not any arithmetic, just some geometric definitions we need to know. First of all, parallel lines, you're no stranger to them because you've used them before. Parallel lines are two coplanar lines that do not intersect. That's the formal geometry definition that's important to know. Here's a pictorial example. So we have two lines, M and N. We know they're parallel not just because it looks like they won't intersect, but because they're marked with these arrows, which makes them parallel. So it's given information if you were doing this in a proof style. Now, you're probably used to this definition, but you're not probably used to having the coplanar part in it. So the reason why we include coplanar in there is because there are also another type of line called skew lines that don't intersect but are different from parallel. So we use that to differentiate parallel and skew. Parallel lines are in the same plane. Skew lines, same definition, but are not coplanar. So they're two lines that are not coplanar and do not intersect. So something like this. You have line Q and line R. They're not parallel because they're not going in the same direction, but they're still not going to intersect. So those special types of lines are called skew. They're in different planes. One's in the plane that's at the top of the box. One's in the plane at the bottom of the box. So you can see that they're in different planes, which is why they're never going to cross each other. And we've talked about this a little bit in class, so hopefully that makes sense. I'll also give you a visual example in class when you see me tomorrow. For parallel planes, two planes that do not intersect, and the visual's right over here. Don't need to talk about them being coplanar or not because these are planes, completely different type of category. No such thing as skew planes, FYI, so don't, that could end up in a trick question later. You know, just throwing that out there. If you're not done writing, pause this. Otherwise, I'm going to jump over to our next set of important definitions. If I can get this to work. There we go. Transversal. It's a line that intersects two or more coplanar, so not skew, lines at different points. So it's coplanar. This is all stuff that's flat in the same plane. So here's one line. I'm going to let this dude be my transversal, and then it's going to cross two other lines or more, but I'm just going to draw two, at different points. So it's going to intersect these two lines at different points. So this here is my transversal. I could label that T if I wanted to for transversal. Not very creative. Now, if I had one line that intersected two lines at the same point, it's not a transversal. They have to intersect at different points, like this point up here and this point down there. All right? If they intersect at the same point, that's called something else. We'll talk about that a little bit later in the school year. They're called concurrent lines. Don't worry about it. We'll get there in Chapter 5. Relax. All right. With transversals, we have these special intersections up here and down here that form special angle pairs. Not just these vertical angles or these linear pairs, but other stuff you have not seen before. Boom, like this. So we have 4 special angle pairs. One from the intersection at the top, paired with another angle at the intersection at the bottom. So corresponding angles are special because they're in the same position. Angle 2 is in the top right-hand corner of this intersection. Angle 6, top right-hand corner of that intersection. So they're in the same position, the same spot. Those are corresponding. They're in corresponding positions, the same position. Easy enough. Alternate interior angles, well, interior means they're on the inside of these two lines. If I can get that to, there we go. Alternate means they're on opposite sides of your transversal. So we have our transversal T here. 5 is on the left side, 4 is on the right side. That means they're opposite. They're on opposite sides. Alternate exterior, same idea. They're alternate. One's on the left and 3's on the right, but they're exterior because they're on the outside of your two lines. So one's up here on the outside and 8's down there on the outside. Now, this says consecutive interior. In your textbook, they're called same side interior angles. Just like the other ones, they're pretty self-explanatory. Interior means they're on the inside of your two lines, just like alternate interior. But they're not alternate. They're on the same side. So 3 and 5, both on the left side. They're not on alternate sides anymore. So those are your 4 special angle pairs. We're going to do one example with those 4 special angle pairs. So pause if you're not done writing. All right, if you want to try identifying these special angle pairs on your own, feel free to pause it and then check your answers with me. Otherwise, I'm going to go ahead and answer it. So, corresponding angles. Pick a pair of angles that are in the same relative position. So, for example, angle 1 and angle 5 are both in the top left-hand corner. If you chose angle 2 and angle 6, they're both in the top right-hand corner. Angle 3 and angle 7, bottom left-hand corner. And then angle 4 and angle 8, bottom right-hand corner. Those are all considered corresponding angles. They're matching in the same position. For part B, we're going to look at some alternate interiors. So they're interiors, which means we're not using anything on the exterior or the outsides. We're not going to use 1 and 3. We're not going to use 6 and 8. And they're alternates. That means one should be on the top, one should be on the bottom. So angle 2 and angle 7. And then angle 4 and angle 5. So if this looks a bit messier than usual, I'll have to write from my iPad because the board isn't working. All right, the next one, part C, we're talking about alternate exterior angles, which means we're not going to worry about the stuff on the inside. So let's just get rid of that right there. And they're alternate, so one's in the top, one's in the bottom. So angle 1 and angle 8 would be one example, and then angle 3 and angle 6 would be another. Only 2 pairs of those, unlike corresponding. Corresponding is kind of special. And the last one, sorry about that, it says consecutive. I know it should say same side interior. Different textbook when I initially made this video. Same side. Sorry, it's kind of messy. Again, the iPad's throwing me off. All right, so they're interior, so nothing out here, nothing out here, just the stuff on the inside. Now they're same side, so both are on the same side of your transversal. So for example, 2 and 5 are both on the top. And then 4 and 7 are both on the bottom. You might be asking yourself, well, is there such thing as same side exterior? Yep, totally right, sure are. We're not going to talk about those in this video. We'll get to those a little bit later in either section 2 or section 3. Hopefully I kept the video nice and short for you. Have a great evening. Or morning, or whatever time you're watching this. All right, see you later.